Hi, it's Mrs. McDaniel, and I'm here to talk about the very first section in Chapter 9, Evaluating and Solving Logarithms. So, I will tell you that this sounds very difficult and scary, and it really is not that bad. So, if you look at the success criteria, it says change between logarithmic form and exponential form. This is one we're going to do today. So we're not going to do all the notes today. We are going to focus on this one. And then we're going to also focus on evaluating logarithms. We are going to save solving logarithmic equations for a second day. So we're kind of going to go a little slow to make sure it all sinks in and we understand it. So it says logarithmic functions and expressions. So they do show you this graph, which can be a little bit confusing. It just says consider the exponential function f of x equals 2 to the x power. So that's an exponential function. We know that's a growth function. It will grow as it goes up from left to right. So that would be that blue function and its inverse. So the inverse, recall that you can graph an inverse of a function by interchanging its x and y values. So you just put y where x is and x where y is. And so basically it just flips the values. You guys can see the two charts. And so over here, it kind of gives you a little paragraph. The inverse of y equals 2 to the x can be defined as x equals 2 to the y. In general, the inverse of y equals b to the x is x equals b to the y. In x equals b to the y, the variable y is called the logarithm of x. This is usually written as y equals log bx, which is read y equals log base b of x. So this is a little confusing, I know, but basically what we're doing is we're doing the inverse of an exponential function. That's all a log is. So it'll make a little more sense when we kind of get a little deeper into it. But the graph is just a visual of kind of what we're doing, and we're exchanging x and y. Basically, you guys, the answer to your problems today to a log is your exponent. So we are actually going to write that down here. What is a logarithm? A logarithm. I can't say it. I just called it a log for short. So, anyways, it is the inverse of an exponential. So we're going to write that down here. And what you guys need to understand is that the answer to a logarithmic is an exponent. So what we're looking for today is what is the exponent? We know the base and we know the answer, but we're trying to find the exponent. Okay. And also kind of when I looked up like an easy way to explain this online, it's basically up here. I'm going to just write this so you guys can see it. To what power, so that's an exponent, to what power must we raise a base number to get a certain number? So we're looking for that power or that exponent. So I wanted to put that in there because that's kind of an easy way to explain it. And then we'll kind of keep going with this and hopefully it'll make a little more sense. So exponential form versus logarithmic form. So I'm going to show you what exponential form looks like. We know exponential form looks like something like this. B of x to the y, where b is your base, x is your exponent, and y is your answer. So b to the x equals y is how we would say this. B to the x power equals y. That's kind of how we would say that out loud. So what a log looks like, and they do actually use the word log, is it looks like this. Log b y equals x. And that b is like a subscript. So when we read that, we say log base b of y equals x. Log base b of y equals x. So b is still the base. The little subscript number is the base. X is the exponent and y is the answer. So they're just kind of inverse, basically. So I wanted to write that down. And one of the common logs, just so you guys know, if there is no log there, like if they don't have a base number, usually we're using base 10. So often we're going to have a log there. So, all right, this first example, what we're going to do on these first two examples is we're just going to convert back and forth from logarithmic to exponent form, or exponent form to logarithmic form. So if you guys look at this first one, it's in exponent form. We can all agree 2 to the 6th power is 64. But if we want to write that in log form, the base is 2, so it'll be log base 2 equals 64, or well, it doesn't equal 64. Log base 2, 64 equals 6. So 6, your exponent is your answer. Just like it is up here where we had written this right here. So your exponent x is your answer when you write it in log form. So you're just kind of switching it around so you can get used to seeing what it looks like. So the next one is 4 to the 1st equals 4. So this would be log base 4, because our 4 is our base, of 4 equals 1. So basically that's still 4 to the 1st power equals 1. But what we're looking for is what is the exponent. And there is a little button on your calculator that will help you do this, but we're not to that point yet, but there is something on there that will help you. So this next one, a little tricky, but the base is always that first number. So log base 5, 1 equals 0. 0 is your exponent. And again, we're just rewriting this in log form. So we're just moving some things around and putting it in inverse form. So the next one is a 5. This is our base. Here's our exponent, which is our answer, and then it's our answer in log form. So this is going to be log base 5, 0.04 equals -2. And remember, we know that when we raise a number to a negative power, it just becomes a decimal. Okay, the next one is 3 to the x power equals 81. This one doesn't have an answer for the exponent, it just has a variable. So this will be log base 3 of 81 equals x. And then the final one will be log base 3 of 1/9 equals -2. So when we raise 3 to the -2 power, we get 1/9. So this is just a back and forth. So we're going to practice that on our homework, and hopefully that helps you out there. Example 2, convert from logarithmic form to exponential form. So we're just going to go backwards. So when I look at this, remember this first number here, this 10 was my base. My exponent was this number here. So it's 10 squared equals 100. Let me make that squared look a little bit better. Okay. So again, this is my base, log base 7. So the base 7 raised to the 2nd power will give me 49. When we look at log 8 of 0.125 equals -1, this is going to be log base 8 to the -1 power will give us 0.125. Example 10, log 5 of the log 5 of 5 equals 1. So this is going to be the base of 5, log base 5 to the first power will be 5. And then example 11 is log base 12 of 1 equals 0. So log base, our base is 12, our exponent is 0, and our answer would be 1 in exponential form. And then finally, the last one, it's a fraction, but it'll be 3 as the base, negative 3 as the exponent, equal to 1/27. All right. So again, hopefully that back and forth helps you to kind of understand what they look like. So we're going to move on to kind of evaluating them, which it can be kind of tricky. You may want to use your half sheet for a little bit of help. Here it says log 2 32. So basically we're looking for what exponent is going to give us 32 when the base is 2. So this is kind of the equation we're looking at. When the base is 2, what is that x value so that we can get 32? You can use your half sheet to help you. I know that 2 to the 5th power is 32. So I'm going to go ahead and put x is 5. Again, that half sheet of paper that we had, you can look across the row of 2 and you can see that x to the 5th power or 2 to the 5th power will give you 32. Now this one is trickier because it is a decimal. So it is, and actually, you know what? We're going to go down and do 7 and 9 first, just because I want to stick without decimals and fractions first. So let's do 7 first. It is log 3, 27. So it's the base of 3 raised to what power will give me 27. Again, you can look at your sheet, but 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. So x is going to be 3 here. I'm not looking for a lot of work. I really would like you to rewrite out this equation so you can understand what we're doing, how we're getting this number. So I would like this equation right here if you can write that. So number 9 is log base 4, 64. So the base is 4. What is the exponent that will solve this? Well, 4 to the second, 16. 4 to the third is 64. So again, it is 3. And we're not going to give you any numbers that are super difficult. Most of these are going to be pretty basic. However, it is going to get a little trickier when I give you some fractions or decimals. So if we look at 11, just finishing up that left-hand column, this is going to be log base 3 to what power gives me 1/27. Well, I want you to focus on the number on the bottom, which is 27. And you can look at that half sheet, but 3 to what power would give you 27? It would be 3 to the third power that gives you 27. If I want it to be 1 over 27, I need it to be to the negative third power. All right, example 6 is a decimal. I'm not sure if most of you guys know that 0.2 is 1/5. But it is 1/5, which would probably help more than a decimal because decimals are kind of tricky, but it is the fraction 1/5, so that we could say base 5 to what power would give us 1/5. Well, 5 to the first power gives me 5. 5 to the negative first power will give me 1/5. So this is -1. Very similarly, example 8 is log 10. So base 10 to what power will give me 1/10. That will be, again, the same. 10 to the first power will give me 10. 10 to the negative first power will give me 1/10. Example 10, log 15, 15. So this one's a little different. The base is 15. Raised to what power will give me 15? Well, that will be 1. And then finally, log 6 to 16. So log base 6. So log base 6 of 216 will look like this. Well, 6 to the second is 36, but 6 to the third is 216. So this will be 216. X equals 3 will give you that 216. I know I went through those kind of fast, so if you need to slow it down or go back and take a look, let me know, or stop the video and rewind. These over here, when we get to this, you guys, we are going to go down a little bit later and look at properties of equality for logarithmic equations. So it does get a little bit harder, but what you really need to understand is how to write these and how they look, because the look is kind of weird because there's a word in there. But as long as you can switch back and forth, and then you can understand evaluating them and understand that we're finding the exponent. The exponent is the answer in a log. That will get you a long way to understanding them. The assignment will be the worksheet. In the worksheet, I will be assigning for you guys is 9.1, and I will have you do 1 through 9 on the worksheet. The first 3 are just rewriting in logarithmic form, rewriting in exponential form, and then evaluating. So there's only 9 questions that you'll be looking at today. So please make sure you get that done. Thanks so much.